right, we are looking at graphing this function right here. G of x is 6x squared. And then we're also asked to compare it to the parent. So we'll basically describe if there's a stretch, a shrink, or reflection. So there's multiple correct ways to do this. I'm going to start off by setting up a table here. Tables are nice because, let's make it the whole thing shown. There we go. You can graph any graph with a table, whether it's a quadratic, an exponential function, linear, or whatever. So we're going to put our standard inputs here right now. This just has an x squared term, so it has not been shifted left or right. So from -2 to 2 are going to work great for inputs. I'm going to use my calculator to input these values for x squared. So let's see, I was doing that earlier. We're going to do 6 times whatever my input value, which is an x value of -2, and I'm going to square that. Making the calculator do the work here for me. Let's see, I'm going to output 24. So -224 is a coordinate. I can repeat that process, and I'm just going to change this guy to a -1. 6 times -1 squared. When I input 0, this is kind of nice. The whole thing is going to become 0, right? When I input 1, it's 6 times 1 squared. I don't really need a calculator at this point. 1 squared is 1, times 6 is 6. 2 squared is 4, 6 times 4 is 24. So now I have all these coordinates that I would want to set up on a graph. So -2, 24, let's see, that's going to be -2 and then up to 24. My graph only went to 15, so it's way off the graph. I don't have to plot that point. I just know by the time I'm at -2, I am very high. My next one is at -1, 6. This one does fit on the graph, and it's right here. Then I have 0, 0. Then I have 1, 6. Now I have the same problem I had earlier with -2, 24 that I do with 2, 24. It's well off the graph. And so that's just good to know. So as I connect this and I try to make my graph, I just know I'm shooting very, very, almost looks like it's vertical. It's not vertical. It's still growing to the left, but it's very tall and skinny. So it's looking like that. Okay. So that's the graph. I've done that part. Compare to parent. So the parent function, hopefully you remember, is this guy. It's just the x squared. The multiplier in front is 1. This is actually a nice little picture of it. Right, the vertex at the origin. I go left and right 1, I'm up 1. Go left and right 2, I'm up 4 because 2 squared is 4. This guy is growing much faster. When I go to the right 1, I'm all the way up at 6. Where this guy to the right 1, I'm just up at 1. It has a stretch. So that's my comparison piece. This is a stretch by a factor of 6. It is 6 units taller. And that's the two things they asked for. They asked me to graph, did it, and compare to the parent function. I did that too. I'm going to add domain and range on here because it's good practice. So let's see, my domain is that x is all real numbers. And I know that because these arrows on the end are telling me that this graph is going up and to the left and up and to the right. So it's going forever left and right. So in terms of the x-axis, it's going both directions. It's hitting everything. My range, however, this graph, this parabola does not go forever up and down. It has a bottom. It only grows up. So it is starting at all real numbers, but my y values have a low value at 0, and then they're up from there. So it's just y is greater than or equal to 0. It's everything above 0, which hopefully we can clearly see from the picture. All right, I hope that's helpful. Message me anytime with questions.